A function g is the inverse function if f of g of x. And so if you remember, this f of g of x is actually composition of functions, which is what we covered kind of in that preview chapter. Okay, you covered it last year in pre-calc. And so basically what they're saying is if you compose those two functions, you get x. And likewise, if you compose them in the other direction, you get x as well. And so how we denote an inverse is we use to the -1. And this doesn't mean to the -1 power. This means actually f inverse. Okay? So there are three kind of statements that are kind of important, and your book actually has these down. And it says if g is the inverse function of f, then f is the inverse function of g. That should make sense. They're kind of buddies. Okay? The domain of f inverse is equal to the range of f. And the range of f inverse is equal to the domain of f. Okay? So real quick, domain of the inverse equals the range of the original function. Range of the inverse equals the domain of the function. So that should make sense. They're inverses, they have some sort of relation. Okay? A function need not have an inverse function, but if it does, the inverse function is unique. So we've got a word here that maybe we haven't talked about before in the past. Unique. What do I know that word means? One of a kind, right? So if it's unique, that means there can only be one inverse function. You can't have more than one. So here we go. We're going to show that the functions are inverses of each other, and so this is the start of your homework. They're going to give you two functions. In order to show they're inverses of each other, you have to have both an f and a g. Okay, you can't just have one. And so we've got two things we need to do. The first is we need to compose the functions f of g of x. And then we're going to compose them the other way. And when all is said and done, if they're inverses, it should equal x. Fairly straightforward. So really what this means is this means f of the cube root of x plus 1 over 2. And all I did there is replace g of x with the g of x function. Now what I'm going to do is I'm going to take this function right here and I'm going to plug it in here for x. Okay. So what this says I do is I take 2 times whatever x is. So in this case, x is the cube root of x plus 1 over 2. I'm going to cube it and subtract 1. Well, what do you know happens to a cube root in a cube? So basically, those cancel. And I'm left with 2 times x plus 1 over 2 because I canceled out the radical, minus 1. So now the 2's cancel out. And it leaves me with x plus 1 minus 1, which you know that just equals x. So you're done with that one. Now we've got to do the same thing the other direction. Okay, so I've got to do g of f of x. So these are kind of like proofs. You're proving that they're inverses. So that means g of 2x cubed minus 1. So what I'm going to do is I'm going to go to the g function, and where I see x, I'm now going to put in this. So what that means is I have the cube root of 2x cubed plus or minus 1 plus 1 all divided by 2. What do you know happens? The 1's cancel. What do you know happens? The 2's cancel. So really I have the cube root of x cubed, right? But you know that the cube root of x cubed is x. So you need to make sure that you show me enough work so that I can follow your steps. Okay, don't like do everything on the first step. You, especially, because I know you like to do that. Okay, so make sure that you show me at least more than one step. Alrighty, so now we're going to talk about existences of inverse functions. And basically, a function has an inverse if and only if it is 1-to-1. So if and only if a function is 1-to-1. So the easy way to determine if a function is an inverse, we are going to use what's known as the horizontal line test. So we had the vertical line test for determining if it was a function. To determine if it's an inverse, you're going to do the horizontal line test. So basically, you're going to graph it. So which of the functions has an inverse function? So if I graph f of x equals x cubed plus x minus 1, if I were to graph that, would that in fact pass a horizontal line test? And so that's going to be your task. We just need to figure out if in fact these do have inverse functions. So does the first one pass the horizontal line test? Does the second one? Okay. So basically, what did the first one look like? The first one looked something like this. Okay. What does the second one look like? So in other words, it looks something like this. Okay. So if those are in fact my functions, can you see how one would fail the horizontal line test? Now there is still a way that we can find the inverse of the second function, and what we need to do there is restrict its domain, and we'll talk more about that later. That means we're only going to look at a portion of the graph, the portion that does fit the horizontal line test. So the next thing, and this is something we did last year, so I don't know if you necessarily need to write these down, because this next example we're going to look at, we're going to follow these same steps. But basically, guidelines for finding an inverse function. The first thing we're going to do is graph it, see if it passes the horizontal line test. If it does, then what we're going to do is we're going to switch x and y. Okay? Once we switch x and y, what we're going to do is we're going to go ahead and, I take that back. Very first thing we're going to do is we're actually going to replace f of x with y. Once we do that, we're going to solve for y, or solve for x, and then the next thing we're going to do is we're going to switch x and y. I think the best thing would probably be to just look at an example, and then you'll see what I'm doing. Okay. So first of all, f of x, I'm going to replace that with y. Okay, that's your very first step. Okay. Next step, what I'm going to go ahead and do is I'm going to go ahead and solve that for x. So to solve that for x, I'm going to go ahead and square both sides. So I get y squared equals what? 2x minus 3. What do I do now? Add 3 to both sides. So I now have y squared plus 3 equals 2x. And then divide by 2. So final step, so I end up getting x equals y squared plus 3 all divided by 2. Final step is to go ahead and switch those two around. So really, I'm going to interchange those. So I get x squared plus 3 over 2 equals y. And then last but not least, I'm going to now change the y to f inverse. Oops. There you go. So that's pretty much it. We're going to call it good for today. We'll continue. We've got a few problems left at the end. So if you want to get started, that's what you're looking at. 1 through 5, 9 through 16, 29 through 32, 37, 38, 71, and 72. Now, I don't know if I gave you page 349 or 348. So if I didn't, you're going to have to look on your computers and get those page 349 and 348. Okay?